Okay, let's consider an example today from your homework, which I'm gonna do show you how to do problem number 3 today. Suppose that two different companies have applied to provide cable television service in a certain region. Let P denote the proportion of all potential subscribers who favor the first company over the second. Let's consider testing proportion equal 0.5 versus proportion is not 0.5. based on a random sample of 25 individuals. By the way, because of the alternative hypothesis, we should set that right here, that the alternative hypothesis is HA, proportion not equal 0.5. Because it's not equal, that means the test is two-tailed. And we have a random sample of 25 individuals. X is going to be how many people in the sample favor the first company. Okay, so if we think about it, possible values of X range from 0 to 25, right? Okay, so random variable X, according to probabilities theory, has a binomial distribution with two parameters, n equals 25, and P will be, depending on what's true, the null alternative, P would be some other number. So some probability of success. By success we mean favoring the first company. Okay, so what you want to do is you want to first of all figure out what's your type 1 and type 2 error. Type 1 error is always going to be claiming the alternative when the null is true. So in this case, that means claiming that the proportion of people who favor the first company is not 0.5, when actually it is 0.5. So claiming that the proportion of subscribers who favor the first company is not 0.5, when actually it is 0.5. Okay, now let's talk about type 2 error. What is that? That's claiming the opposite. Then claiming the null when actually the alternative is true. So let's look and see. Type 1 error is claiming this, so P not 0.5 when P is actually 0.5. Type 2 error is the other way around. P is equal 0.5 versus P is not 0.5. So we'll say claiming that the proportion of subscribers is actually 0.5 when it is not 0.5. Okay, so that's discussion of type 1 error. Now let's go ahead and type 2 error. Let's go ahead and compute the probability of type 1 error and probability of type 2 error. So probability of type 1 error is called alpha, and it's the chance of rejecting the null given that the null is true. So we need to think about what's going to be an appropriate rejection region in this case. So an appropriate rejection region, it depends on the alternative. If your alternative is more than, then the rejection region is going to mimic that and also say more than. If the alternative is less than, then the rejection region is going to say less than. Actually, sometimes, most of the time, it's less than or equal to. But since we have a two-tailed test, the alternative has to include two parts. Either X, which is the number in the sample who favor the first company less than something, or X more than something. So let's imagine that somebody told you what the rejection region is, but it should have two sides. So rejection region is going to be equal to either X less than or equal to some number, which they should give you. Let's say, I don't know, 8. Or X more than or equal to some other number like 13, whatever. No, 13 is not going to work. Maybe 15, something like that, because you don't want to be too close to half of 25, which is 12 and a half. So anyway, so let's say this is your rejection region. So let's continue calculating the type 1 error. It will be probability that X is less than or equal to 8 or X greater than or equal to 16. Okay, so how we need to compute that given that the null is true? Now, when the null is true, what happens? What is the value of the proportion? It's equal to 0.5. So right here Let's say that's when the proportion equal to 0.5. So in order to compute that probability, you have to compute two probabilities. First of all, you have to find probability x less than or equal to a. And then you also have to find probability that, so that's given proportion is 0.5. And then you also have to find probability that x is greater than or equal to 16. That proportion is also 0.5. And then you have to add them up. So here's what you can do to compute this probability. You're going to go ahead and go to StatCrunch. From there, you're going to go to Stat Calculators Binomial. Here, your n, remember, it was 25. And because we assuming the null is true, with the proportion values, whatever is in there, are null. And what was the proportion value in the null? Let's remember that. It was 0.5. Okay, so we're going to leave this as 0.5. And we want to compute probability less than or equal to 8. Okay, we click Compute. We get this number, copy that over here, and okay, so that's going to be that. And then we also want to compute probability x more than or equal to 16. Again, going back to StatCrunch, change this to more than or equal to 16, compute, okay, whatever that is. Okay, copy that. And then you'll need to add them up. Once you add them up, you get your answer. Okay, so I'm going to leave that to you guys. Okay, now we want to find the probability of the type 2 error if the actual value of proportion is not 0.5 but something in the alternative. Because remember, when we're talking about type 2 error, we are saying that the null is true when actually the alternative is true. So when is the alternative is true? But when p is not 0.5. But there are a lot of values of proportion not equal 0.5, so you have to put something there. So we're going to say try and find beta of 0.3, which is not 0.5. Okay, what does that mean? That's probability of not rejecting given that the alternative is true, like for example p is 0.3. Now this is going to be the tricky part. So remember, this was our rejection region. So if x is less than or equal to 8 or x more than or equal to 16, how can it not happen? So think about it. So you have integers here 0, 1, 2, 3, 4, 5, 6, 7, 8, or 16, 17, 18, all the way to 25. So how can it not happen? So what would be your r prime? Well, those would be the integers that will be between 9 and 15. Why is that? Because think about it. If you are not less than or equal to 8, you are more than or equal to 9, right? So you got to be more than or equal to 9. If you are not more than or equal to 16, then you are less than or equal to 15, right? Not 16, because 16 is already included in here. So in other words, you just have to compute this probability, okay? So for beta of 0.3, you're going to have to compute probability of x being between 9 and 15, given that the value of the proportion is 0.3. So here's what you're going to do with that. You're going to go ahead and go to between tab right here in StatCrunch. You're going to change the value of p to now 0.3, and what you want to do is you want to change this to 9 to 15. So this would be 9, this would be 15. Click that to compute. So that's going to be my answer. So I'm going to copy that over here, and we are done with the problem. Thanks for watching.